Good afternoon to all. I'm Deepa from Chemistry Department. I'm working in Erodu Sengundar Engineering College, Tudupadi. We have a subject of Engineering Chemistry. In first unit is Water Chemistry. So this is a conclusion class for Water Chemistry. Okay. We know very well about water. Water is the most important and essential for all living things. There are so many sources of water. The sources are rainwater, seawater, surface water, underground water, lakes water, and also water from wells. So these are the so many sources of water. But from this, only rainwater is the purest form. But the drawback is it is difficult to collect. The other sources are most in impure form. So only water treatment is introduced. So water treatment is nothing but the process of removal of all types of impurities from water and making it fit for domestic or industrial purpose. That is the water treatment or water chemistry or water technology. And according to the presence or absence of calcium and magnesium salts, the water can be classified into two types. One is hard water, second one is soft water. Hard water, that means the water which does not produce lather with soap solution, but it produces white precipitate scum, that is the hard water. This is due to the presence of calcium and magnesium salts. And soft water. Soft water, that means it produces lather readily with soap solution. This is due to the absence of calcium and magnesium salts. Then hardness. Hardness, that means it is a property or characteristics of water which does not produce lather with soap. Reduction of hardness is water is treated with soap solution. It does not produce lather. And also second treatment is water containing hardness. It gives wine red color with eriochrome black tea indicator at pH 9 to 10. Then hardness can be classified into two types. Depends on the types of dissolved salts present in water. One is temporary hardness. So temporary hardness, that means presence of bicarbonates of calcium and magnesium. And it can be removed easily, just boiling the water and also adding lime to the water. Then second type is permanent hardness. Permanent hardness, that means presence of chloride and sulfates of calcium and magnesium. It cannot be removed easily. It can be removed by lime soda process or zeolite process. The total hardness is sum of temporary hardness and permanent hardness. That is the total hardness. The units of hardness are 4. One is parts per million. Second one is milligrams per liter. Third one is Glasgow degree. Fourth one is French degree. And then estimation of hardness by EDTA method. Here EDTA is ethylene diamine tetraacetic acid. The structure of EDTA is shown in figure. Now we have to estimate the amount of hardness present in hard water by using EBT indicator. The needed solutions are EDTA solution, standard hard water, EBT indicator and buffer solution. There are 3 titrations. First one is standardization of EDTA. Here we have to pipette out 20 ml of standard hard water into a clean Konica flask and add 5 ml of buffer solution and also 2 to 3 drops of EBT indicator. The solution becomes wine red. The solution is titrated with EDTA solution is taken in the burette. The end point is wine red to steel blue. After the end point, you have to note a burette reading. It is consumed to be a V1 ml. And second titration is estimation of total hardness of water sample. You have to pipette out 20 ml of the given hard water sample into a clean Konica flask and same titration will be repeated. The burette reading is noted as V2 ml. And third titration is estimation of permanent hardness of water sample. Here is also you have to take 100 ml of same hard water sample into a 250 ml beaker and boil it for 15 minutes. After boiling, the water can be cooled and also take 20 ml of hard water sample into a clean Konica flask and repeat the titration as it same. Here, the volume of EDTA be consumed as V3 ml. After the calculations, you have to calculate the total hardness and also permanent hardness. So from these temporary hardness can be calculated from total hardness minus permanent hardness. So here by using EDTA, you have to estimate the amount of hardness of water sample. The next topic is boiler feed water. So boiler, that means it is an instrument used to convert water into steam. Boiler feed water, that means the water is fed into the boiler for the production of steam. It's called boiler feed water. Boiler feed water should be free from all types of impurities, that means turbidity, oil, dissolved gases, alkali and hardness causing substances. If hot water is enter into the boiler, some troubles may arise. The troubles are formation of deposits, priming and foaming, third one is caustic embrittlement, fourth one is boiler corrosion. First one is formation of deposits. That means when water is continuously converted into steam in boiler or any one of the heat exchanger, the concentration of dissolved salts in water increases rapidly. When it reaches saturation point, they forms precipitate. Depends on the formation of precipitates, the deposits can be classified into two types. One is sludge, second one is scale. Sludge, that means the precipitate is loose and slimy. This is due to the presence of magnesium chloride and magnesium carbonate. And scale, this is due to the presence of calcium hydroxide, calcium sulfate and magnesium hydroxide. Calcium bicarbonates. And then requirements of boiler feed water is hardness less than 0.2 ppm, soda alkalinity 0.15 to 1.0 ppm, caustic alkalinity 0.15 to 0.45 ppm and excess soda acids 0.3 to 0.55 ppm and dissolved gases like CO2 and O2, these are nil. Then second one is priming and foaming. Priming, that means the process of production of wet steam. This is formed by high steam velocity, high water level in boiler and sudden boiling of water and poor boiler result. These are the reasons for priming. Then prevention, controlling the velocity of steam, keeping water level lower in boiler, sudden boiling of water must be avoided and also using good boiler design. And foaming, that means the formation of stable bubbles above the surface of water is known as foaming. So foaming is due to the presence of oil and grease in water and also finely divided particles in water. It can be prevented by using sodium aluminate, sodium hydroxide coagulants, and also it can be prevented by adding anti-foaming agents like synthetic polyamides. Then third one is caustic embrittlement. So caustic embrittlement, that means intercrystalline cracking of boiler metal. So a boiler must usually contain small portion of sodium carbonate. It just reacts with the boiler metal to produce sodium Na2FeO2. This again reacts with the water. This forms sodium hydroxide and carbon dioxide. The sodium hydroxide increases the crevices as in the boiler. So due to this, some cracking arises. This is known as intercrystalline cracking. Then it is prevented by using sodium phosphate softening agents instead of sodium carbonate, and also can be prevented by adding tannin, lignin to the water. And next topic is softening or conditioning methods. That means the water is used for industrial purpose should be free from hardness producing substances, also other impurities. The process of removing of hardness producing substances from water is known as softening or conditioning methods. The softening or conditioning methods are two types. One is internal conditioning, another one is external conditioning. The external conditioning, that means removal of hardness producing salts from water before feeding into the boiler. These are also two types. One is demineralization or ion exchange process, second one is zeolite process. Then we have to discuss now demineralization or ion exchange process. In this process, we have to remove almost all ions, both cations and anions in hard water. Here two types of exchangers are used. One is cation exchanger, second one is anion exchanger. The resins are having functional groups. For example, cation exchanger is having cation functional groups. It is going to absorb cations present in water, and anion exchanger, that means it is having acidic functional groups that is going to exchange anions present in water. The process is hot water is first passing through the bed of cation exchanging column. It will absorb all types of cations present in water. And second, the cation free water is then passing through the anion exchanging column. Here anion exchanger removes almost all anions present in water. Finally, the water coming out from ion exchange process is known as deionized water or demineralized water. The diagram is shown in figure. Then regeneration, that means cation exchanger can be regenerated by adding HCl, and anion exchanger can be regenerated by adding NaOH. And then advantages is the resulting water is highly pure, highly acidic and also highly alkaline water can be treated in this process. The water containing very low hardness. And disadvantages is water having turbidity, Fe and Mn cannot be treated. And also equipment is costly and more expensive chemicals are needed. And second type is internal conditioning. Internal conditioning, that means we have to remove the scale forming substance from water from boiler by adding some chemicals directly into the boiler. The chemicals name is boiler compounds. Carbonate conditioning. The internal conditioning are classified into four. First one is carbonate conditioning. In carbonate conditioning, we have to add sodium carbonate into the boiler. Sodium carbonate by removing scale forming substance. Then second one is phosphate conditioning. And here we have to add sodium phosphate conditioning agent. We have to remove scale forming substance. And third one is Kalkan conditioning. So Kalkan, that means it is a sodium hexametaphosphate, Na2 Na4 PO3 6. This is the formula for